Sewage treatment is a really important way to keep our waterways safe for not only organisms but ourselves. Okay, we know since the late 1800s that sewage-borne bacteria leads to infectious diseases. Okay, we know that our sewage contains a lot of bacteria, and it can make us very ill. And we learned we really had to develop better sewage removal, okay, and treatment. Before 1900, for example, we just dumped it. Okay, we really didn't understand the full magnitude of what we were doing, not only to our ecosystems but back to us. Okay, when we think about raw sewage pollution, when we think about what ends up at our sewage treatment plants, for example, there's a lot of different things that are in that water that leaves our homes, our businesses, our industry, okay, and go down our, literally down our sinks and our toilets. There's a lot of things in there that we certainly wouldn't want dumped right out into our waterways. Our Clean Water Act, states, from back in 1972 that we can't dump our untreated sewage anymore. All right, up until the 1970s, there was still some untreated sewage being released into the environment. Raw sewage pollution includes things like, even big things like debris, rags, plastic bags, sand. Okay, also what we call particulate organic matter, or POM. Okay, organic matter like food, garbage, fecal material. Okay, that goes down our sinks and our toilets. Dissolved organic matter like bacteria. Okay, things that are dissolved in the water that we can't necessarily see, not like food particles, but dissolved in the water like bacteria. There's dissolved inorganic material like nitrogen, phosphorus, other toxic materials that go down sinks, for example. Phosphorus that comes out of our detergents, for example. And those all, if you have municipal treatment, if all your water goes to your town for treatment, it goes off to your municipal treatment site, and those things are addressed. Keep in mind that when we talk about sanitation and sanitary sewers, etc., and we talk about our household sewage, okay, things from our toilets, our sinks, our showers, etc., okay, those are either going to go, that water is either going to go into the ground in your yard, in your septic tank, or it's going to go off to your municipal sewage treatment plant. You're in the streets, often you'll see storm drains. Okay, there's in some towns you'll see that those drains will go to sewage treatment, but in most cases those storm drains go directly out to our waterways. So, for example, I know in Niles they have storm drains. If you look at them, they have little fish on them. If that water goes directly out into our environment, into our waterways, and it doesn't go to sewage treatment. Okay, so raw sewage, it contains a lot of nasty things that really need to be addressed before they're released out into our waterways. Okay, when we think about removal of pollutants, like I said, either it goes to treatment or it goes into our septic tank. The first thing that we're going to talk about is that municipal treatment, those steps involved in getting our water prepared for it to be sent out into the environment. On your outline, you'll see that I listed up a number of steps that are involved in cleaning our water and preparing it for discharge as effluent. But I'm going to go through it in terms of this diagram so we can kind of look at it together. At first, we have what's called the preliminary treatment. And as the water comes into the sewage treatment plant, the first thing that is done is it's sent through multiple screens in this grit tank. And that removes solid objects. Remember, you're going to have paper, you're going to have toilet paper, okay, whatever ends up down the toilet. If your kid puts a toy down there, whatever it is, okay, something that's flushed. If it's a solid material and it can be screened out, that's the first thing that happens. So basically, any kind of floaters are removed. Anything that doesn't fit through the screen is removed. And some things settle out in the bottom of the settling tank, and those things will be removed. And any solids that are removed are going to be sent to a landfill like garbage. So we could prevent having to do that if we could just make sure we don't send any of those things down our drain, because clearly it ends up in the same place. It just is another process that has to be done at the sewage treatment facility. Okay, any kind of oils and greases that are removed from our entire process are going to be treated in some way, whether it's from going to be digested as sludge, or it's going to be chemically treated separately. Okay, so those things have to be removed as well through our process, and they are removed in multiple places along our process. Okay, this number 2 is our primary treatment, or the primary clarifier. Okay, where oils, greases, and solids are removed as well. Okay, so it's kind of like it allows a lot of the particulate matter to settle out. It's going to spend a decent amount of time here to just let it settle out. The fats and oils will float on top. We know that they float on water, and those will be skimmed off. And like I mentioned, they are often sent to that sludge digester that you'll see kind of halfway down on the right side. Okay, where again, those are organic matter, and they can be broken down by anaerobic bacteria, okay, that can basically biodegrade them. All right, so that's taken care of there. In number 3, we have what's called the aeration basin, and just like it sounds, it's an area where we pump a lot of oxygen into it. The water becomes aerated. Okay, this is an area where we remove biological nutrients, okay, dissolved organic matter. Okay, we use natural decomposers in detritus feeders to break down biological, material. Okay, so we have decomposable material, certainly a lot of it, in our sewage. And there are organisms we can use to break down that material for us. So basically what happens is we have different types of bacteria that go in there, that are already, that exist in there. We also often add bacteria to our aeration basin, and what happens is we add the bacteria, okay, we circulate that bacteria, we pump oxygen in there, and all of this aerobic bacteria take in the oxygen, they take in the nutrients, all the organic matter, okay, they use it as food, okay, they decompose it for us. And the oxygen just really drives that process, because the more oxygen they have plenty of food, they can decompose more and more and more, they can grow, they can divide and do more and more and more. Okay, so they do kind of a great step for us in that process. You'll see on the screen there, it says microbes, those bacteria consume the organic matter for us. Okay, so they can break it down pretty quickly within the right conditions. Okay, in number 4, we have what's called the secondary treatment, or the secondary clarifier, where any remaining fats and oils are removed and sent to the raw sludge digester. Okay, so you'll see that off to the side there again. Okay, any more that is removed is sent there. In this step, sometimes we'll try to remove, depends on the plant, they'll try to remove nitrogen and phosphorus from the water before discharging the effluent into the waterways. We have bacteria that can remove nitrogen from water and turn it into nitrogen gas. Okay, these are what are called denitrifying bacteria. Denitrifying bacteria, they can take in nitrogen in the water and change it into nitrogen gas, which it comes out of the water and goes up into the air. And we call that process denitrification. So again, what we can do is add these denitrifying bacteria to the water, give them some oxygen, okay, and they'll be delighted, and they will remove the nitrogen from the water, and that can prevent a lot of that that eutrophication that we talked about previously. Okay, finally, in that last step, filtering and disinfection. Okay, again, now we know we have bacteria in our water that comes out of our homes. And now we've also added all this bacteria along the way to do jobs for us. We can't discharge all that bacteria into the environment. So in that final step, water is treated to kill all the bacteria that was in the water, and we added to the water. In the United States, chlorine gas is the most used way to get rid of that bacteria. Okay, we kind of treat the water with chlorine gas, and that kills the bacteria, kind of like you would chlorinate your pool, okay, to make sure bacteria doesn't breed in it. All right, so there's a couple different ways. You'll see there it says water can be filtered with coal and or sand, and or it can be disinfected with chlorine gas that we use, or even UV light. Okay, but generally speaking, like I said, in the U.S., we use chlorine gas. All right, they have to be removed. All bacteria, we know it, they are pathogens. They can be very harmful to us in the ecosystem, so they must be removed before the effluent is discharged. Okay, we call discharged water from the sewage treatment plant effluent, and it's discharged into the river, streams, oceans, etc. Or sometimes we can use that effluent water on lawns, golf courses, or for industrial purposes. All right, before we kind of leave our conversation, I want to talk a little bit about the sludge treatment. So off to the right, remember we sent some of our materials to sludge treatment, and basically these are areas that are basically digesting vats. Okay, so we have anaerobic digester. That means we have organisms in there, bacteria, that can respire anaerobically. They don't need oxygen. So we can send them these like sludge cakes, and the bacteria will basically break this material down for us. Okay, there are microorganisms that can decompose much of that sludge. Okay, sludge is a gray, foul-smelling liquid, as you can imagine. When it's digested, this is a good thing, okay, because again, we get a lot of it. We can basically use that sludge cake as fertilizer. As long as all the pathogens are removed, we can compost it when it dries out. Okay, so again, we can get rid of it because there's a lot of organic matter there. Okay, we basically heat it up and kill the pathogens in it. Like I said, we can use it as fertilizers. We can then, as long as it's safe, we can landfill it, we can incinerate it. But we have to treat this material in some way to make sure that it is safe. Okay, we could also, again, incinerate it, and we could generate electricity from it. Okay, there's a lot of different things that we can do to deal with that material. If you don't have municipal treatment for your sewage, then chances are you have an individual septic system. So there's a couple other ways that we can deal with our waste. Earlier, right at the beginning of the semester, one of our topics that I gave you as an option to read about and make some decisions about were reconstructed wetlands. So we'll talk about that in a minute. But I want to talk about our individual septic systems. So often people have septic systems in their yards, or what we call a septic tank, more so in rural or suburban areas. If you're a little bit more on the outskirts of your city limits, you might have an individual septic system for your yard. So basically, your water from your homes, your washing machines, your sinks, your toilets, your showers, will go down the drain, and it will go out into this septic tank. Okay, the water goes out into a drain field, and the water percolates into the soil. The particulate organic matter settles out, okay, and that's basically what happens. It's this big tank, this big space out in your yard, underground, and all your material that you send down there goes down there. So the idea is you really only want to send down things that are going to be able to be digestible, that are going to be organic, that are going to be able to be biodegraded. Okay, we don't want to send things down there and challenge septic. There's a lot of bacteria out there that can help digest that material. If you put Rid-X down your drain, for example, that can boost the metabolic activity of the bacteria there, digesting the waste, the organic matter. But in addition to that, you really need to be pumping out your septic systems, because not everything is going to be able to be broken down. So every couple of years, depending on how much water you use, how many people you have in your household, will depend. But basically about every 2 to 3 years, that's something that families need to consider, okay, to actually have it removed. And what happens is, you can call a company. There's a lot of companies out there that can do it, and they come and they pump out your septic into their big truck, and then they take it off to sewage treatment. So that's where it ends up eventually. But again, there's not all the pipeline system underground to get it off to the wastewater treatment plant, so it needs to be carted by truck. All right, the other way that we can treat our waste is through what we call a reconstructed wetland. We know that wetlands are kind of nature's way of cleaning up waste, okay, natural waste. These areas that are very biodiverse, and they have the organisms, the microbes, the algae, the aquatic plants that can clean up wastewater. So the idea is that we could make these reconstructed or artificial wetlands, and they could deal with our waste. But, that is something that it could only handle so much waste. So we have to be careful about what we're putting in there. And obviously, like, for example, in our natural systems, they don't have toilet paper. So there's things that we have to be careful with, and we can't overload the wetland, because it won't be able to assimilate our waste if we overrun it. Okay, currently there are about 500 artificial wetlands in the United States, but they are only really targeted to probably a small building, a small community, a school, okay, areas that they're not going to overrun the ability of that wetland. Our last slide is about regulation. Okay, we think about the Federal Water Pollution Control Act of 1972 that then became renamed the Clean Water Act. And the Clean Water Act, or the CWA, sets what we call water quality standards based on the concentration of pollutants. And what that is national recommended water quality criteria. And there's about 150, 160 chemicals that are regulated chemicals and substances. And it basically works through, or at least with point source pollutants, it works through a permit system. Basically these point source permits for discharge. So that's how it's regulated. Like I mentioned earlier with point sources, we can identify the discharge points and then monitor them and make sure there's not excess discharge going out into our waterways. Okay, for different pollutants, there's what we call the TMDL, or the total max daily load. The TMDL, the total max daily load. Basically saying, okay, this is how much you can discharge. This permit says you can discharge this much each day. And that's basically figured out, how much can this waterway assimilate, all right? What is not going to have a negative impact on the environment where the discharge is occurring. So basically, it just makes sure that that body of water isn't going to be overrun with that type of pollutant. We want to make sure that that environment is going to be able to assimilate the pollutants that are going into it. And that's determined by, like I said, the total max daily load determined by the Clean Water Act. Okay, again, it's really hard to regulate non-point source pollutants. They don't have, it doesn't work the same way. You can't say, oh, to a farmer, this is your total max daily load for nitrogen. Okay, it doesn't work like that, because obviously there's going to be days where more nutrients are going to get washed away. Maybe there's a lot of time it's not being fertilized. It's much more difficult to deal with that. Okay, and most of our rivers meet the standards that are set by the Clean Water Act, but unless we have some kind of major disaster, that there's an excess amount of discharge into our waterways.